So I've got a question for you. Return values. Functions and methods return values all the time. What do you use them for?
Output.
Output. OK. Does anybody do anything else with them?
Checking that the thing worked, and if not, well,
Checking the thing worked.
Yeah.
OK. Does anybody else check that the thing worked? Deathly silence.
there's a mixture of stuff. Well, somebody might throw exceptions, somebody might return error. True, there's all-
OK, so we're not talking about exceptions. We're talking about normal return values. OK. So, all right, let's use a concrete example then. I'm assuming you've all used PHP's PDO module to talk to a database. So the rough way the code works is you compile a statement, you create what's called a prepared statement. So you take your SQL, you compile it, you pass in the parameters that get injected into the placeholders, you send that off to the server, and then the server sends you back some results. OK. Right? With me so far? Right. How many of you who've used PDO would write the code like that? First of all.
I might have done in the past.
You might have done in the past. OK. So you've obviously spotted a deliberate mistake. OK. You'll see that in regardless of how the stuff's fetched back, you'll see this basic pattern all the time. Execute the code and then iterate over the results of the statement to fetch back the rows to process them. That's a normal pattern for dealing with database retrieval. There's a problem, though. How do you know whether or not the SQL's worked? How do you do that? Does anybody know?
Does that return the... Sorry.
Has the PDL got different modes? You can tell it to throw an exception, or you can tell it to just return a dummy value.
I do believe it can throw an exception. I don't use that myself, but I do believe it can.
Does the statement execute return the thing?
It does. This is what the code should look like. The statement actually returns a value, a Boolean, to say whether or not it succeeded. And you're supposed to check it before you try and fetch any data. Because if you don't check it and just try and fetch data, it'll look like your SQL worked and there was no data found. That's what it will look like. So if you've passed in bad SQL, you've got a syntax error in your SQL, for example, or you've passed in parameters that aren't compatible with the SQL, you then have a robustness problem that you aren't detecting if you're not doing this check. Now, we didn't have a room full of people saying that people check return values, which is a good job because that means this slide still hasn't aged too badly. Yeah. Especially on large projects where you've got 40. I've worked on projects with over 50 developers. And certainly when you get to that scale, no one's checking the return values 100% of the time, everywhere. No one's doing it. It just doesn't happen. The reason for that is because we're all human. Humans are crap at doing anything 100% right. That's what computers are for, but humans are crap at that. It's not our strong point. Excuse me. All right. So sometimes they don't check it safely. This is one of the things PHP gets bashed for all the time. Strings, yes? You get return values from strings. You actually have to compare it to false. You can't just do not, because of the way PHP, sort of the equivalent of Ruby duck typing, the way PHP will typecast something in order to make code work. Well, we're going to take advantage of that a bit later on, by the way. But, yeah, so this is something where people don't check return values correctly, and they should do. You do string position, for example. It can return 0 upwards if it finds a match, and it returns false if there isn't a match. Unfortunately, if the string you're looking for is at the start of the thing you're searching, that triggers, and it shouldn't do, because this is the safe check at the bottom. And people do that everywhere in PHP code. God, I've lost count how many times I've done it. We all do it, because it's a bad API design. But you can't rely on checking it at all. You just can't. People don't do it. And you can't enforce it. Even if you've got a team of people checking the developers. Who checks the checkers? Who watches the watchmen? You can't win with this. So One of the first things I do to make code robust is get rid of return values that are used in this way. Get rid of them. You can't rely on people checking them. So even if you detect a fault and you raise a fault, it doesn't matter because no one knows the fault's occurred. You've got a robustness problem that people aren't detecting because you're relying on them to do the detection. You're not doing the detection. You're relying on them to do it. So get rid of this. That's the first thing. So if we take our query, and now, so with something like PDO, I wrap this in a function to make it safe for other people to use. So at least it's checked in one place and nobody else has to check it. So this is how we were calling it beforehand, before we wrapped it. And if we wrap it, this is now what it looks like. So what it means is, if line 4 here is reached, and we'll come back onto that in a moment, it means you know that the SQL at least had no errors. Doesn't mean there's any data. That's a correctness issue. Whether or not the SQL's found the data you were looking for, that's a correctness problem. That's to do with your algorithms and your input validation and all the rest. But this is making sure you haven't got a robustness problem. It makes sure that your SQL is definitely executed. So it's quite difficult sometimes to work out what's robustness and what's correctness. So, you're happy with that so far? Right then. So there's another part of this pattern is what do you do once you've actually detected a problem? Originally in PHP, you exit 1. Or die. How many of you have seen code with exit 1 and die in? Yeah? And what does it do to the state of your system? And what does it send back to the person who's called your web page when it happens?
Just a white screen of death.
White screen of death. But the point is most of you don't know or don't remember, and I don't remember until I did the research for this. You'll get a HTTP 200 back to the caller. The caller thinks everything's worked if they're calling an API. If they're, obviously a human looking at the white browser pages going, ugh, they're not happy. And obviously if you're doing an e-commerce website or something, they'll go and use your competitor if your website's not working. So what are the things you can do when a problem's happened that don't involve die and don't involve exit 1?
Throw an exception.
Throw an exception. OK. Anyone disagree with that? How many of you use exceptions in your code? Most. Sorry?
It's something I always wonder how many to use, or like.
OK.
I feel bad using them a lot of the time. But
So,
Well, it seems more the question is how do you catch them and deal with them after you found them?
OK, how do you catch them and deal with them? In that case, then, I'm going to show you guys something very different. We're going to use exceptions, but not like perhaps how you've seen them used before, then. I've got a slightly different thing. And remember, nobody does anything 100% of the time. Remember that as a guiding principle. So if we take our query, we've said we want to throw an exception of some kind. And I'm deliberately throwing a garbage exception here because that's not important. We're going to replace that later on in the talk with something else. Right, it's just showing that the thing to do is to throw an exception. In case anyone doesn't know, the whole point of an exception is it stops the normal flow of execution happening. It's like an old-fashioned interrupt for anyone who's done any hardware programming. It's a very rough analogy. But it stops the happy path happening, so at least the damage can't get any worse. Fingers crossed. You never know. So as part of this pattern, then, when you can't carry on, throw an exception. That's the thing to do. Interrupt the flow of the code. Now, I'm very pleased I didn't hear this. What about returning null? Yeah, I've done this. I've returned null to show an error. PHP is full of things returning null and false instead of throwing exceptions because a lot of the APIs in PHP were built before exceptions existed in the language. Anyone do this? Who's willing to admit it? Yep.
yeah.
Yep. Right. Please don't. Or don't anymore. Don't anymore. Anyone who's got any familiarity with Java in particular will be aware of how null can really mess a system up, especially if you're using a language that treats null like it's being shot in the head. But the problem's not null itself. The problem is how people use null. Null's not an error report. That's not its purpose. That's not what null is there for. So please stop using it, and stop using true and false as well, like PDO does, as error responses, because you're relying on people to check those values. People don't check values 100% of the time, so you can't rely on it. So please don't do it. Now, there are times when, oops, kind of gave it away there. So there are times when null is a good idea. Null exists to show you that data should be there, but isn't. It means no value. It's not like void, where void means there never should be a value ever. Null means there could be a value, but we haven't got one at this time. For a customer at the minute, I'm finishing up a data API that powers a football-related website. And what I'm doing is I'm putting online 100 years' worth of historical data about football matches. So if this stuff goes back to the 1800s, the data is incomplete. For some of the matches, we don't know where it was played. We haven't got that information. Maybe one day we'll have it, but for now we don't. So where there's gaps in the data like that, that's exactly what null's job is for. But if no data is not a valid answer, throw an exception, please, to help start making your code robust. So this is pattern number 1, and I call it succeed except when you fail. That's what I call it. I'm not witty, so it just sort of came out as I was putting the slides together. And it's got 3 key points. You build APIs that succeed, so people don't have to check return values for success or not. They can assume that if it's got a return value, it can use that return value safely. When an API can't succeed, that's what exceptions are for. Exceptions are the tool 100% of the time. With one caveat, which I've got a slide for later on. And use null only when you're returning data. Don't use it to indicate success or failure. Use it as a piece of data. So that's pattern number 1. How are you feeling about that so far? Make sense?
Yeah.
Anything controversial in there? Nope. Oh God, you're an easy crowd. That's awesome. Why did I wait years to come up here? I really should have come here sooner.